All right, let's jump right into your deep dive on choice under uncertainty. This is all about giving you the concepts and the problem-solving chops you need to absolutely ace your exam. Here's what we're going to cover. We'll start with the ideas behind signals and trust, then get into the math of expected utility. After that, we'll define risk attitudes, and then, most importantly, we'll walk step by step through how to solve the two big exam question types, advisory and search problems.
So what's at the heart of all this stuff? It really boils down to one core problem: asymmetric information. That's just a fancy way of saying one person in a deal knows a lot more than the other. And that gap in knowledge creates a huge trust issue.
So how do you solve that? How do you bridge that trust gap? With signals. But for a signal to actually be believable, it has to follow two key principles. First is the costly to fake principle. It's right in the name. The signal has to be so expensive that a bad quality seller just can't afford to fake it. Then there's the full disclosure principle. This one's a bit more subtle. It basically says that since buyers assume the absolute worst if you're silent, good sellers have every reason to just share all the information they have.
And you see these signals everywhere in the real world. Think about it. A huge, expensive ad campaign, a low-quality product couldn't possibly afford that long-term. A lawyer in a super high-end suit, that's signaling a long history of winning cases. And a really good product warranty, that's a perfect signal of quality, because it would bankrupt a company that sells junk.
Okay, now let's get into the math behind these decisions. The main tool you're going to use to solve pretty much any problem here is the expected utility model. You absolutely have to get this down.
So what is expected utility? Well, it's a really important shift from just calculating expected value. Instead of just averaging the money you could win in a gamble, you first change those dollar amounts into units of happiness, or utility, using a utility function. Then you average them. It's all about the expected satisfaction, not just the expected cash. And this is the formula you've got to know. The expected utility is the sum of the utility of each outcome, U of xi, multiplied by the probability of that outcome happening, pi. You're going to use this one again and again on your exam.
Now, from expected utility, we get this really useful idea called the certainty equivalent. All it is the guaranteed amount of cash that would make you feel just as happy as taking the risky gamble. You can think of it as the gamble's no-risk price tag for you, personally.
The risk premium is simply the difference between the gamble's expected monetary value and your personal certainty equivalent. So what does this number actually mean? It's basically the amount of money a risk-averse person would pay to avoid the stress and uncertainty of the gamble.
So why do different people have different price tags for the very same gamble? Well, it's because we all have different attitudes toward risk, and we can neatly classify these into three main types.
So how can you figure out where you stand? Simple. Just compare two things: a guaranteed pile of cash and a gamble that has the exact same expected monetary value. Which one would you choose? Your answer tells you everything about your risk profile. Okay, this table right here, this is huge for your exam. It connects everything: your risk attitude, what you'd prefer, and the actual math shape of your utility function. So a risk-averse person will always take the sure thing, and that corresponds to a concave utility function. A risk-neutral person, they don't care either way, so their function is a straight line. And a risk seeker, well, they love the gamble, which is modeled by a convex function. All right, enough theory. Let's put this into practice. The first big type of problem you'll see on the exam is the advisory problem. This is where you have to figure out the best course of action when the outcomes aren't certain. Here's a classic example. Zoe can either not pitch and get a guaranteed income of 64, or she can pitch and face a gamble. Now look at her utility function, the square root of y. That little detail tells us she's risk-averse. So what should she do?
The good news is, the process for solving this is always the same. It's just 3 steps. First, you calculate the expected utility of the risky option, pitching. Second, calculate the utility of the safe, certain option. And third, you just compare the two. Whichever one is higher, that's her best choice.
So let's run the numbers. The expected utility of pitching comes out to 6. The utility of not pitching is just the square root of 64, which is 8. And since 8 is bigger than 6, the certain option gives her more utility. So the final answer is Zoe will not pitch.
Now here's a pro tip for your exam, especially when the problems get more complicated with multiple stages. If you draw out a decision tree,
Always solve it by working backward. Start from the final outcomes at the end and work your way back to the very first decision. It's a method called backward induction, and it keeps everything logical and organized.
Okay, let's tackle the second major type of problem you'll face, the search problem. This is all about figuring out when to stop looking for a better option, especially when searching itself costs you something.
The rule here is actually pretty simple and intuitive. You keep searching as long as the expected benefit of one more search is bigger than its cost. The moment that expected gain is less than or equal to the cost, you stop. Simple as that.
Let's walk through an example to see how this works. So Nico gets wage offers that are spread out evenly between 50 and 150. Every time he looks for a new offer, it costs him $2. What we need to find is his reservation wage. That's the magic number where he's perfectly indifferent between taking the offer he has and searching just one more time.
And just like before, there's a clear, repeatable process for this. First, you write out the formula for the expected marginal benefit of another search. Second, you set that benefit equal to the marginal cost. And third, you just solve the equation for that reservation wage, W star.
So where's that formula come from? Well, it's basically the average gain you could get from another search times the chance you'll actually find a better offer. We set that benefit equal to the cost of 2, and then we just solve for W star. The calculation shows his reservation wage is $130, and that becomes his rule. He'll turn down any offer below $130 and accept anything $130 or higher.
So that covers the main models and the two big problem types. But to really lock this in for your exam, you need to practice. For a full summary and a bunch of practice tests, go check out gradeguru.nl.
All right, let's do a quick recap of the absolute must-knows. Always use the expected utility model for these kinds of decisions. Remember, your risk attitude is all about the shape of your utility function. For advisory problems, you compare utilities and always work backward. And for search problems, you stop when the benefit equals the cost. Good luck with your studies.